Well, 6, please. Chapter 4-3. You guys should know this. SOA, yes? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you know those 3 trig functions, then you automatically know the other 3 trig functions because they are reciprocals is the math word that I'm looking for. Opposites, not so much. So they are reciprocals, which means cosecant is hypotenuse over opposite. Secant would be hypotenuse over adjacent. And cotangent would be adjacent over opposite.
They should make one tonight.
Really?
I'm not lying.
Really, I'm not sure what that is.
I'm not sure what that means. There, that's better. That works. Okay, now I give you this level little triangle. Wherever your angle is at, you have to be able to rewrite and find opposite hypotenuse and all that jazz. You with me? There are 3 angles in a triangle. One of those angles is a 90-degree angle. Across from that 90-degree angle will always be the hypotenuse. Depending upon where you place the other 2 angles, depends upon where your opposite and your opposite adjacent are.
Writing. I'm just sucking it all.
Now, I have several different Greek letters up there: alpha, beta, gamma, theta, and phi. You may use any of them. If I go up. Oh, it's in my garden. Yes? If I go up.
No, what are those alpha and what is
Those are just angles. They can replace anything. They can be the gamma. They can be the alpha. The angle. It's always the angle.
Why can't you just use X?
Because you cannot use X and Y because X and Y are points on the unit circle. Those points represent the sine and the cosine value. So if you're asking for the sine of X, which later on we'll be using X, but X is going to be more of a variable. Sorry? You could use anything. You really could. You could use anything. They're all just placeholders. But generally speaking, we've always used Greek letters for whenever we're doing trades. Let's be near to the Greek table. You ready? Okay, moving right along. I give you this triangle and I ask you to find the 6 trig functions using the drawing. Now, some of you may recognize what the last leg of that triangle should be, but please do not yell it out because I want you to be able to locate it mathematically without just saying, hey, I know that it's a number. Okay?
Hit him again, because now I know.
She's trying to make me fall.
So now, with that said, I need to find my opposite hypotenuse and adjacent according to my angle theta. What is 3 according to theta? It is the adjacent leg. What is 4 according to theta? This is your opposite leg, which means the last one that we do not know is the hypotenuse. It is directly across from the 90-degree angle. Now, what theorem from geometry did you have to use to be able to find the last leg of the triangle?
A squared plus B squared equals C squared.
Right triangle, you use the Pythagorean theorem, a squared plus b squared is equal to c squared. A is 3 squared plus b is 4 squared is equal to c squared. So 3 squared is 9, 4 squared is 16. What is 9 and 16? 25. The square root of 25 is 5 is equal to your c value, which is your lovely hypotenuse. Do we understand how we came up with all that? A squared plus b squared equals c squared. Carpenters, you should love, love, love that theorem. You should. Okay. I said carpenters should love that theorem. Okay? Now, with that said, the next thing, we need to find the 6 trig functions. So, if I'm finding the sine of theta, sine is what? Opposite over hypotenuse. What's the opposite side? 4 over 5. What's the cosine of theta? That would be adjacent over hypotenuse. 3 over 5. And what would be the tangent of theta? 4 4 over 3. Do we all understand that? So if you have those 3 trig functions, then you automatically have the other 3. So what is the cosecant of theta? 5/4. What is the secant of theta? 5/3. And what is the cotangent of theta? 3/4. Do we all understand how to find that, yay or nay? Not really?
I don't really know the last.
It's easier to just write social code and then pass down along.
That right there. That tells you exactly what you have to know. Because sine is the opposite leg, opposite is 4, over your hypotenuse, which is 5, where I came up with 4/5. You see that? Cosine is your adjacent leg, which is the 3, over your hypotenuse, which is the 5, 3/5. Tangent is your opposite leg, which is the 4, over your adjacent leg, which is the 3. Why it's 4/3. Do you see that? Now these 3 are just the reciprocals of sine, cosine, and tangent. That's it. Are we good? This is exactly like problems 1 through 16. So with that said, tonight's homework is 1 through 26 all. This is not difficult material. This is something that you should have done in geometry. So this should not be a new concept. Cosecant, secant, and cotangent might be new, but the rest of them should not be. So let me get you started on tonight's homework. Are you ready? Bless you. Now, on page 274, the directions say, find the exact values of the 6 trigonometric functions of the angle theta shown in the figure. Use Pythagorean theorem to find the third side of the triangle. We just did an example on that, did we not? Is everybody's book open to 274? Page 274. Problems 1 through 4, you do exactly like I just did in class example. Problems 5 through 8, it says find the exact values of the 6 trigonometric functions of the angle theta for each of the triangles. Explain why the function values are the same. Look at those triangles. On number 5, look at the triangle number 5. On number 5, this is what you have. Can you tell me? You have a 6 and a 2 and a 3 and a 1. It's doubled, right? 3 times 2 is 6. So my hypotenuse went from 3 to 6. This leg went from 1 down to 2. This leg went from 2 square root of 2 down to 4 square root of 2, which means this is a double triangle. It's a bigger triangle. These are similar triangles, not congruent triangles. Similar triangles have exactly the same what? Angles. The lengths of the sides change, but they're proportional to a small unit one, right? So since they are proportional, they're considered to be ratios, which means all you have to do is know that since they're similar triangles, their sine and cosine and tangent values will be exactly the same. Now, I'm eliminating your homework. Are you listening? 5 through 8. You do not have to do all trig functions for both triangles. You know why? They're going to come out to be the same. So I'm eliminating half the homework for you. You only have to do the big triangles. Why do I want you to do the big triangles and not the little triangles? Because whenever you simplify the big triangles, what will you get? The little triangles. Do you understand that, yes or no? So for 5 through 8, only do the big triangles. Okay? Well, I'm not going to give you credit. I mean like that. Single tier. 9 through 16. It says sketch a right triangle corresponding to the trigonometric function of the acute angle theta. Use the Pythagorean theorem to determine the third side of the triangle and then find the other 5 trigonometric functions of theta. Number 9. Here we go. Sine of theta is 5 over 6. So what you have to do is basically draw a triangle. Oh, that's enough. So there's my triangle, and there's my level little 90 degrees. That is definitely crooked. I don't like that triangle. Here. There, I cheated. There's my 90 degrees, And now I have to do theta. So I'm going to put theta here. I'm going to put 5 across, and I'm going to put 6 over here. Why is 6 there? Why am I putting 5 and 6 there? Because sine is known as opposite over hypotenuse. Do we understand that? So now, what do I have to find? I have to find my b value, which is going to be my adjacent. This is opposite. This is the hypotenuse. And now I need to find my adjacent. Okay? So a squared plus b squared is equal to c squared. A is 5 squared. B we don't know. C is 6 squared. So 25 plus b squared is equal to 36. Subtract the 25, and I have b squared is equal to 11, which implies b is the square root of 11. True statement? So now I know this is the square root of 11, which is my adjacent side. Now what did it ask for? All the other trig functions. So I'm going to simply write this down that the sine of theta was given, and that is 5, 6. So what else do I know? The cosecant immediately. If I know the sine, then I know the cosecant. What's the cosecant? 6 over 5. Now, what's the cosine of theta? Cosine is known as adjacent over hypotenuse, so that's going to be the square root of 11 over hypotenuse, which is 6. Which now tells me what's my secant of theta. Now, 6 over the square root of 11, which I don't like because it's not what? It's not rationalized, so multiply by the square root of 11 over the square root of 11 to give you 6 square root of 11 over 11. There's my secant. And now I need to find my tangent. My tangent of theta will be opposite over adjacent, which will be 5 over the square root of 11. And again, that's going to give you 5 square root of 11 over 11. So what is my cotangent? Square root of 11 over 5. You're going to take this part of the fraction and flip it. Do we understand that? Do we all understand 9 through 16? We good? Okay, I do not have a sticky note right now, but you all need to have a sticky note. Okay? I'll see if I can get you one, but for tonight, you're just going to have to write this down. Now, the next thing I want you to do is we need to calculate the sine. We need to calculate the tangent of 30, 45, and 60 degrees. Okay? So let's calculate the tangent of 30 degrees. Well, that's going to be the point square root of 3 over 2, 1/2, correct? Remember the hands of the clock, the x-coordinates? So that's going to be, I don't want them like that. 30 degrees is pi over 6, which relates to this point. And if I want the tangent of that, that means I want y over x. And what is y? 1/2 divided by the square root of 3 over 2 is going to be 1/2 times 2 over the square root of 3, which is 1 over the square root of 3. Don't write it on the sticky note yet. Now, this is the tangent, right? This is also equal to the square root of 3 over 3. That is the tangent of 30. So if you have a sticky note, what you need to put on it is that the tangent of 30 degrees is equal to 1 over the square root of 3, which is the square root of 3 over 3. That will help you so that you know immediately what you're doing. Now I'm going to tell you, I'm going to show you mine so that you know how to write it on your sticky. See this? Nice and big, centered in the middle so that you can see it. Don't write it small. The whole point of this is so that you don't have to look hard for it. Okay? Well, yeah, now I can do a lot of things. Think of that as one thing I did do for you. 45 degrees is pi over 4, which is the point square root of 2 over 2, comma the square root of 2 over 2. Yes? Now, we are going to do the tangent of that, and the tangent of 45 degrees is going to be y over x, which is the square root of 2 over 2 divided by the square root of 2 over 2. What is that value? 1. So again, you come over to your level little tangent. Tangent of 45 degrees is equal to 1. I come back over here. Now I need to do my last angle. which is 60 degrees, which is pi over 3, and that corresponds to the angle to the point 1/2 square root of 3 over 2. And I need the tangent of this, which is y over x, which is going to be the square root of 3 over 2 divided by 1/2, which is going to be the square root of 3 over 2 times 2 over 1, which is the square root of 3. Do we understand that? Again, I'm just showing you how I get these. This is something your brain should already be able to do. This is why I'm flying through it. So here, the tangent of 60 degrees is going to be the square root of 3. Now that you have all those values there, the next set of problems is 17 through 26. Now I'm telling you straight up, for problems 17 through 26, you will have a part on the test where it looks exactly like this, where you are going to have to figure out the degree, the radian, and the value. You will have your brain and a piece of paper and a pencil, and that's it. No calculator. The test is next week.
Wait, huh?
For 17 through 26, you will have a test on that part. Okay? It'll be part A without a calculator. Now, what it's asking you to do is to construct an appropriate triangle to complete the table. You don't need the triangle because what do you need? Quad 1 in your head, don't you? All you need is quad 1 in your head. Okay? Now, for number 30 or 17, it says the sine of 30. Well, what radian measures is 30 degrees? Pi over 6. And in quad 1, 30 degrees is at the 3 o'clock hour, right? So I want the sine value of that. So what's the sine of pi over 6? What? 1/2. Okay? Now, the cotangent. I want to know the cotangent of the angle that has the square root of 3 over 3. Which would imply what? This would imply that the tangent of this angle would be 3 over the square root of 3. You know what they did? They rationalized that. So what angle has a tangent of the square root of 3? 60. Let's mess that up. 60 degrees, which means that's pi over 3. Did you see how they gave me cotangent and I went ahead and I did the tangent of it? The tangent of that would be 3 square root of 3, and if I rationalize that, that's going to give me 3 square roots of 3 over 3, and cancel that out to give me the square root of 3. So what angle has the tangent of the square root of 3? 60 degrees. Do we understand that, yes or no? Do we all understand how to fill this entire chart out now? It's going to be harder. You're going to have to think on this one. This one's the part where your brain's going to actually have to think. The other ones, you're going to be on autopilot the whole time. Any questions? The rest of the period will be yours to work on this, and you have plenty of time to get a good start on this in class. True statement? Okay, folks. You guys in?
Do I have a skill check cap under your chair?